of deformed bodies or theory of velocity. So there many equations we see, they are differential equations, right? Even in your strength of materials also you saw, right? What bending equation, m is equal to m by ei is equal to d square by dx square, right? That is the differential equation, bending equation. Similarly, so there are many equations. I think already you encounter such equations in UG itself. So in PG also you are going to witness many such equations. So now we'll discuss what is initial and boundary value problem. Okay. So when you are solving any problem, right? If initial conditions are given, right? So many times when you dy by dx equation is there, differential equation. If you differentiate that differential equation to find out y, you get a constant c. How to find out these constants? These constants are evaluated by using boundary conditions or initial conditions. In most of the time, in dynamic problems, we deal with the initial value problem. That is, at time is t is equal to 0, display y is equal to 0, right? dy by dt, if it is involved at time t equal to 0, we say it as y equal to 0. At time is equal to t is equal to so and so. Okay, value of y is this much, maximum. Such conditions we use, that they are called initial value problem, right? So whereas some examples are also given here, right? So these equations are clearly very visible in the printed notes, right? You go through these equations. I'll share the printed notes. And a general second order equation such as find u of t such that satisfies the second order differential equations and initial conditions. So these are the examples of initial value problems. Okay, these now right now they are not clearly visible. You can go through them in the printed notes. So that I am going to share. Next. So in boundary value problem, okay, you want to find out the integration constants, right? We give the boundary conditions. So what are the boundary conditions? I think last year you saw double integration method, Michaelis method, you solved the deflection problems. There at x is equal to 0, deflection equal to 0, right? At x is equal to L by 2, slope is 0 in simple support beams. Such conditions we give. They are called as boundary value problems, right? So these are some of the examples of the boundary value problems. So if it is difficult to remember these equations, you can also write in the examination the equations of the beam equation, double integration method, Michaelis method equation. Those equations also you can write, right? Next problem can be both initial value and boundary value. Sometimes we deal with same problem, right? We need to use both initial and boundary conditions, right? So those problems are also there in our practice. Differential equations governing the dependent unknown also contain an unknown parameter, and it is required to find both dependent variable and the parameter such that the differential equation and associated boundary conditions are satisfied. Such problems are called as eigenvalue problems. In eigenvalue problems, what happens? You need to find out an unknown parameter. So that unknown parameter is required to be found out in such a way that the differential equation and associated boundary conditions are satisfied, right? Like in our buckling problem or vibrations problem. So what we involve with, they are called eigenvalue problems. That in buckling problems we deal with the eigenvalue problems. We need to find out the unknown variable in such a way that that unknown variable is both dependent variable and parameter, and it also satisfy the differential equation and associated boundary condition. In such a way, we need to find out the unknown parameter. Right. They are called eigenvalue problems.